very happy to invite Professor Roland Good to give us a talk, which is entitled Improving the Efficiency and Effectiveness of Instruction with Progress Monitoring and Formative Evaluation in the Outcomes of the Driven Model. Professor Roland Good is Associate Professor at the University of Oregon in the Department of Applied Behavior and Communication Sciences. His research interests include dynamic indicators of basic early literacy skills, assessment and intervention for the academic learning problems, and assessment in cross-cultural context. Professor Good heads the team of investigators developing the dynamic indicators of basic early literacy skills, which many of us know as the DEBLs, which is one of the most popular tools used in identification and monitoring of children from kindergarten to school. Professor Good has published many papers in scientific journals as well as book chapters, and we're very happy to have him here with us.
Yeah.
Well, thank you very much, and thank you for the opportunity to come, and thank you for coming back from lunch so quickly. I don't know about you, but I feel like sitting back for a nice nap. So I'm going to be talking about progress monitoring and formative evaluation. And I see this as a really critical piece for effective interventions, with some caveats and some issues yet to be worked out. So what I want to do first is sort of talk about why progress monitoring and formative evaluation might be important to look at. And a way of looking at progress that is very frequently used, and that is slope of progress estimated with an ordinary least squares line. But there are issues there, and I want to raise those issues and propose an alternative and discuss a couple of studies that we have done. So first, what is progress monitoring and formative evaluation? And this is sort of from the Student Progress website, which is a really good definition thereof. But the idea of progress monitoring is to start with current levels of performance. Where are they at the beginning of our instruction? And then I'm going to identify goals for that student. And the goals are a really important piece of this. And then measure progress regularly. This is not pre-post. This is more along the lines of once per week or once monthly. There's variations in the way it may be monitored. Then compare the actual progress the student is making and the desired progress. And most important, then adjust your teaching and instruction based on what it is that you see. It's the adjusting of the teaching that makes it be a formative process instead of just admiring the problem is sort of the idea. My interest in this has really spanned my education and research career. And I'm really driven by this as a part of intervention, as a part of a tool for teachers to do something about it. And I received sort of renewed inspiration in that way from John Hattie's work on visible learning. And he did like a meta-analysis of meta-analyses looking at 138 influences on student achievement. And I'm especially interested in those things that we can do something about. I mean, the students are the students. I can't say, no, give me students that I want. They're just there. And selected findings are relevant to this discussion from Hattie. He found that desirable goals were a very important part of being effective in changing outcomes. And he found an effect size of 0.56 in the zone of desired effects just for having powerful, effective goals for what it is that we want to accomplish. Feedback to teachers and to students. Is it working? What do we need to do to adjust that? That in itself had an effect size of 0.73. Goals and feedback. Just doing those things adds to the effectiveness of whatever we do. He found that progress monitoring and formative evaluation, out of all of the effects that he looked at, had the on student achievement with an effect size of 0.90 for just including that piece. So including progress monitoring and formative evaluation in any intervention that you do can be expected to increase the effectiveness and efficiency of that intervention. So as we're looking at this, we need to look at the mechanism of progress monitoring. What do we need in order to do this well and in a data-based, data-driven manner? I would argue we need a framework within which to determine if progress is adequate or not. Just because it's going up doesn't mean it's going up enough. We need a way to use that then to guide our information. We need to use a measure that is defensible at a student level, that is reliable, meets adequate standards of reliability, validity, provides a normative context, and has decision utility. Within our work, we've really proposed what we term an outcomes-driven model, which goes through 5 steps in providing services for a student. Identifying students who may need support, validating that need, and you can do that with a retest, making a plan and implementing the support, and that's where goals would come into play as you design your plan. Evaluating and modifying support, and that's where some sense of evaluating progress is going to be important. And reviewing outcomes. Has our progress been adequate? Here's an example of the problem with Ryan, named after my son, but it's not really him. It just reminds me that this is important. This is about real kids that we're dealing with. And this is a picture of what progress monitoring might look like for a student. So across the x-axis is the week after the benchmark assessment. So I've been providing instruction for 1, 2, 3, 4, up to 22 weeks of instruction. On the vertical axis is their score in oral reading fluency, words correct per minute. And this would be a powerful measure of reading rate that can be obtained in a very timely manner. You notice the repeated measures are kind of all over the place. This is pretty typical of what you see in progress monitoring. We need a way to judge progress for this student. The overwhelming majority of time, that's done with what is called an ordinary least squares estimate of slope. And you're fitting a plain old regression line to that data, where week is your predictor variable and score is the dependent variable, and you get a regression line. Now this is actually providing 2 pieces of information that's very important to us as educators. One of them is an estimate of where you're actually starting. What are the beginning skills of that student? The second piece is the slope of progress for that student. So at the beginning of year, this student had a score of 41 words correct and is making progress at a rate of 0.6 words per week. And it's that slope that would be used to say how much progress would be desirable and is that enough. So our first study is really looking at that characteristic of slope. Now this idea of slope is intuitively appealing to us. It's a direct measure of whether or not kids are going up. It's called learning. It's what they're supposed to do. And we want to make educational decisions in a timely fashion. So what we did was we looked at the use of progress monitoring by schools. And we started with our full data set had 151,000 students in it, for which there was some amount of progress monitoring. Maybe 1 or 2 data points, maybe not really enough to use as decisions in the way that we would recommend. From that, I selected subsets of that overall data set. And what I'm looking at is the how slope would function under optimal conditions. We're getting a fairly dense array of data points, about 1 per week, and I want to look at that decision at 6 weeks, 10 weeks, 14 weeks, 18 weeks, and 22 weeks. I wanted them to have, for 6 weeks, at least 5 data points. That meant that they could be missing 1 week in their progress monitoring, but this is really quite high-quality progress monitoring for making decisions. And this way I can examine the length of time needed to make a decision. You'll notice my sample size is plummeting as I do that because I'm being more restrictive as I select a subsample. And when we get down to 22 weeks, I only have 99 students left, or bottles of beer on the wall, or something like that. So one of the first things we looked at is the reliability of that slope estimate. So if I'm going to make decisions based on 0.6, I need to examine the reliability of that piece of evidence. And you'll notice at 6 weeks that is fairly atrocious, right? I mean, it's really hard to look yourself in the mirror when you say, I'm making decisions with something with the reliability that approaches 0. By about 18 weeks, we go up above 0.5, and we're above 0.5 at 22 weeks. So how good is that? Is that good enough? Well, Salvi, Eiseldike, and Bolt recommend a reliability of 0.90 for important educational decisions. Now, never fear, they recommend a reliability of 0.8 for screening decisions. Well, what about progress monitoring decisions? They recommend a standard of 0.7 for making progress The lowest that they will accept would be 0.6 for group and administrative decisions. Now, right away, you sort of see a fundamental problem with looking at slope. The problem is, it takes me forever to make a decision that's not very good. Right? I don't want to wait like 18 weeks to make an instructional decision about whether or not I need to change my instruction. But before that, it's just unacceptable levels of reliability. So therein is the problem and the tension for me. I pretty much devoted my career to doing this stuff, and as I look at the metric, I'm going, ooh, this is not filling me with confidence. My feelings about that are not alone. In this little measurement niche that spends time looking at this is becoming an increasingly common perspective. Our Dwayne, Chris, Marina, Cormier, and Kimbio talk about the conclusion across multiple studies seems apparent. CBMR progress monitoring is not an evidence-based practice for modeling growth of individual students in reading. I would argue throwing out all the progress monitoring is premature, but certainly the use of slope for making those decisions is problematic. We need an alternative. I've recently been looking at an alternative proposed by Becca Brenner in 2011 called student growth percentiles. And this approach looks at how abnormal a student's growth is by examining their current achievement relative to academic peers who started at the same place. And so we looked at this, and an advantage is I don't have to estimate slope. I have to estimate where a student is at a point in time to use this approach. I've implemented this in our work with Dibbles as pathways of progress, and this is one implementation of this grander idea of student progress percentiles. And I'm using this just as an example of how we do this. So my first step is to estimate for every level of initial skills, the 20th, 40th, 60th, and 80th percentiles. And that's illustrated in this picture. Across the horizontal axis is every individual level of beginning skills at the beginning of the year. This is a picture of third grade, and I'm going to illustrate illustrate this for kindergarten as well. The horizontal axis is where students get to at the end of third grade. Every dot is actually a quintile. This is where students get to if they start at that point. Then our next step is to fit a spline quantile regression line to those quantiles. And you can see I can fit those quantiles really very well. What that does then is divide the outcomes into 5 groups with an equal number of students in each group. So this represents the 20th, 40th, 60th, and 80th percentile of outcomes given the initial skills of the student. So in the Ryan example, he started with an 85 composite score. So I would be comparing Ryan to others with the same level of initial skills. So I'm going to ignore everybody else when I'm looking at Ryan. From that I can then identify if they get to 79 or higher at the end of the year, that would be well above typical progress. But if they're between 61 and 68 at the end of the year, that would represent typical progress, and below 52 would be well below typical progress. I can take those endpoints and use those for progress monitoring to evaluate progress. So in this, I'm not estimating slope. I'm estimating where a student is at any point in time to make a judgment about progress. For example, at 22 weeks, I can draw a line from where Ryan starts to where he gets to, and linearly interpolate where he should be at 22 weeks. So in looking at Ryan, I don't have to do all of that data collection. I'm just focused on the last 3. I can estimate his performance at 22 weeks very clearly based on the average of 3 data points. So the last 3 had a mean of about 61.33, and I can see that would be between the 60th and the 80th percentile. I describe that as above typical progress. From this approach, I'm using an estimate of level, not an estimate of slope. So how would that compare to an estimate of slope in terms of reliability? And you'll notice, as I look at, even at 6 weeks, an estimate of where the student is, their reliability, is at 0.9 or better, even at 6 weeks. That's a pretty dramatic payoff over and above using slope as my estimate for that student. In our next study, we really wanted to look at whether or not this idea of pathways of progress is important. Does it matter? Now remember, I am separating in this discussion initial skills, where the student starts, from the progress that the student makes. And in this, I'm going to look at 2 cohorts of children. I'm going to look at a K1 cohort, and I'm going to look at where their skills are at the beginning of 1st grade. Or at the beginning of kindergarten, I'm sorry. And at the beginning of kindergarten, I can identify risk with a surprising and frightening degree of accuracy. But more important is the progress that they make important. So we followed those kids through kindergarten and into 1st grade, and I looked at their outcomes at the end of 1st grade. And I'm going composite to composite score here. At the beginning of kindergarten, they're not actually reading. I'm identifying risk based on phonemic awareness and letter naming fluency. But at the end of 1st grade, I'm looking at their actual reading skills. So that reading is going to be a really important part of that outcome. I'm also looking at this in a 3-4 cohort, which is looking at their beginning skills at the beginning of third grade, plus their progress in 3rd grade. And is that linked to where they begin in 4th grade? 35,000 kids from kindergarten into first grade, and 7,000 kids from third grade into fourth grade. And just a very brief word about the composite score. I'm going to refer to composites here. And as I talk about a composite, what I'm doing is putting together a small number of extremely brief indicators. And these indicators include reading rate, the number of words read correct in a minute. It includes reading accuracy. I'm going to look at the percent accuracy, and I have a lookup table that gives a weighting to that in the equation. I'm also going to look at reading orally for understanding, where the student reads out loud and then tells me about what they have read. And I'm also going to look at silent reading for understanding and using meaning from context, a Days adjusted score. Days is our humorous way of saying a Dibbles maze measure. So it's a maze measure, but if it's a Dibbles maze, it's Days. So overall, the composite represents reading for meaning at an adequate rate with a high degree of accuracy. And I really like the composite because I just am convinced that a student needs all three of those things. Those three are the essential components to be on track as a reader, is the idea. And 2 out of 3 of those is just not enough. You need all 3 of those. So in this one, for the K-1 cohort, we looked at their beginning of year skills at the very beginning of kindergarten. So they are just walking into school for the first time. And then we looked at their progress. Now, you notice the Fs are really not very interesting, but it is kind of thrilling to get an F of 4,900. I don't get Fs of that size very often. What's more important here is the eta squared, and this is the proportion of variance in first grade reading outcomes that is explained. And beginning of year kindergarten risk status is explaining about 31% of the variance in whether or not they're a reader at the end of first grade. That's kind of scary. Their progress is adding another 19% to that. So we're getting it up to about 46% of the variance explained by the end of, with kindergarten beginning skills and with their progress. So about half of whether or not a student is a reader at the end of first grade is explained by looking at what they bring to kindergarten and their progress within kindergarten. The status by progress interaction effect was significant, but explained that essentially 0.3% of the variance. So it's not a huge concern, but it may be of interest. Now, with a sample size this large, I feel reasonable confidence in these eta squareds, and I think this is the important part to interpret from this one. So what does that mean in terms of actual outcomes for students? And this is looking at initial skills. And across here is their initial level of skill. And it's divided up into 5 clumps of students, or 5 levels of initial status. The first group is described as well below benchmark, and these are students who will probably not, based on the information at the beginning of the year, they probably will not reach the end of first grade benchmark. And that end of first grade benchmark, here is their end of first grade composite score, and the horizontal green line is the end of first grade benchmark goal. So students who reach that level at the end of first grade have reached the lowest level of really okay reading skills. Notice they're not super readers, they're okay readers, but they're really okay readers. those who are below benchmark. And the odds for this group are about 50-50 of reaching later literacy skills. Then there is above benchmark, and the odds are ranging about 60 to 85% that they'll reach future goals. This is sort of very solidly above benchmark and very high above benchmark. So we're able to sort of divide that above benchmark group into 3 levels. You'll notice that you're a whole lot better off being in that well above benchmark group than in being in the below benchmark group. And really that's explaining about that 30% of the variance in reading outcomes. But within each level of risk at the beginning of kindergarten is the progress that is made. So this is well below typical progress. Orange or yellow is below typical. Light green is typical. Above typical progress in dark green. And well above typical progress in blue. So even for students who are starting well below benchmark, if they make well above typical progress, they're solidly on track for reaching that outcome and are actually rather comparable to those students over here who started at the highest level of initial skills but made very poor progress. So the progress is important. And it seems to be important regardless of the level of initial skills that you start with. There was that small interaction effect that explained 0.3%. And I think that is because the growth here for that lowest group is having a larger payoff than growth over here for that highest group. And you can sort of see how differences in rate of progress make that differential impact across those two. Now we looked at this also for the 3-4 cohort. And again, I'm most interested in that eta squared. In this one, the interaction effect is actually not significant and explains 0.1%. It actually kind of was significant at the 05 level, but at this point, nobody cares. There are some similarities and differences as I look at 3 to 4. A striking and I would argue frightening difference is the huge role that skills at the beginning of 3rd grade play in the reading skills at the end of 3rd grade and at the beginning of 4th grade, explaining about 66% of the variance. In other words, no matter what teacher you put that kid with, 2/3 of the variance is explained by the skills that they brought to 3rd grade at the beginning. We know how frightening that is. I think really important here is the additional 6% of variance explained by progress over 3rd grade. And we can look at those differences in the same way. You'll notice that the payoff is not as dramatic for being in higher levels of skill at that point. But there is always a payoff in any of the initial levels of skill in terms of 4th grade, beginning of year skills as we look across them. So conclusions. I am desperately seeking something that will work better than slope to make decisions about progress. I think that this idea of student progress percentiles offers some potential advantages. The reliability of what I get for each student to make a decision is much greater than the reliability of the slope. And the progress that we can classify in that way appears to be related in an important way to later outcomes, either 1st grade outcomes or beginning of 4th grade outcomes. There are important limitations to that conclusion, though. The data set that I used represents current practice It's not gathered under research commissions. I have not trained those people personally. That would be like way too much training for me. So a downside is I really don't know the fidelity with which the assessment was done. The upside is that this really represents the way these measures are currently used in practice. Also, these rates of progress were not experimentally manipulated. They were observed in what children did. I'm interested in looking at that rates of progress because it seems to me they are potentially manipulable. This could be an outcome of an intervention study or randomized control trial where we would look at rate of progress, typical, above typical, well above typical, as an outcome variable to interpret the effectiveness of our intervention. Finally, I talked about measurement week, like 22 weeks. That represents a straight calendar week. I couldn't take into account individual school calendars and vacations, so it's sort of an approximation thereof, but not as exact as the idea. If I have sparked your interest, a place that you can go for further information would be the dibbles.org website, and it has information about pathways of progress and other work and research that we have done with those pathways. So thank you very, very much. Oh, I know you. You ask the hard questions. I have other questions. No, I'm kidding. So in grade K progress, 19% of the variance is explained by progress, and by the time we hit third grade, 6%. This is, you really honed in on something that I think is huge. This is huge. If you want to check that, and what do I make of that? I make of that really a couple of things. One is, if you want to change the future for a student, don't wait to third grade to do it. Kindergarten is our moment of opportunity. We can teach these skills, we can make a difference. Their progress very early is essential. Second, this is just rather frightening about third grade. A whole lot of our emphasis, especially around reading first in the U.S., has been focused on they need to be on track for reading by the end of third grade. I'm sorry, the beginning of third grade, it looks like we've missed our moment of opportunity. We need to be on track before the beginning of third grade. Where you are at the beginning of third grade is huge in predicting where you're going to be in fourth grade. So we need to intervene early. I would also add it's never too late to do it. We can still make a big difference there.
Can you go to the one where you show the component formula? Thank you. So how do you come up with dwarf would be times 1, the original score would be times 2 and times 4? Do they represent any conceptual difference between those components, or they just came up experimentally? How are these coupled? Why is this one opposed to dwarf would be multiplied by 10, the retail by 3.5, and the dwarf by 5? How do you come up with those numbers?
That's a really important question because there are multiple different ways that you could weight components to create a composite. I could use a regression weighting, I could use a factor analytic weighting, I could use linear discriminant function weighting. I didn't use any of those. What I used was Robin Dawes talks about the robust beauty of improper linear models. And so this is actually, I love saying it's an improper model. I just think all our models should be somewhat improper. But what it does is essentially weights each of the components an equal amount. So one doesn't contribute more than the other. And the difference in the weights is actually driven by the difference in the standard deviations of the measures that are underneath it. So I'm using an equal weighting approach to do it. Partly that means that, man, you can't get to the composite by just like reading as fast as you can and missing every other word. Both are given equal weighting in that composite.
Thank you very